A linear system is two or more linear equations. Okay, there's three things that can happen when you graph lines. Okay, say this is one line. And then another line. Like that. And then the third line. Okay, so the three things that can happen when lines are on a plane is one, they can meet at one point. Sorry, they can meet at one point. This green line and this blue line meet at one point. This, okay. So they can meet at one point. This red line and this green line are meeting at all the points. Right? They're meeting at all the points, which means they're the same line. So they can meet at all the points, which means they're the same line. Okay. What's the third thing you think that can happen with the lines? Either they can meet at one point, they can meet at all the points, or what's the third thing you think could happen?
They can never meet.
They can never meet, right? It's like a Tinder for lines, like a little match thing. So either you find a match one time, you find a match and you guys stay together forever, that's gross. Or you don't find a match and you never meet, which means you are the same line. Not the same line, but you have the same slope. Okay. So they can never meet. And those are the only three situations you have. They're like, okay, so now we're gonna have, instead of one equation, we're gonna have an equation for this line, an equation for this line, an equation for this line, and maybe an equation for some other line that's out there. And Weber-Stein may ask you to find the parallel lines, the lines that don't meet, or they may choose the two lines that meet at one point, that intersect at one point. Choose the two lines that happen to have the same slope, or choose the two lines that will never meet. And they can ask you the same thing in a bunch of ways. So we'll just take it. I really want to keep this graph, but it's nice, but I'll make another one. Okay. So let's graph some lines. No, actually, okay. Graph the line y equals x minus 1. And the ways you can graph, or you can put it in the slope-intercept form, plot your intercept, and then move the way the slope tells you to move. Or you can do table of values. I should write this down. You can put it in slope-intercept form, which will show you the slope and the y-intercept. So you can plot the y-intercept and move along with the slope. One way. You can use a table of values. The X and the Y thing, and see if I pick X as 0, what do I get for Y? If I pick X as 4, what do I get for Y? And do that at least, I would like you to do that at least 3 times so that you can see that they're all on the same line. Or you can, I don't know, I guess you can find another point on the line and just plot the 2 points and not plot the slope. So sorry. I have a new mouse and this does its own thing. Okay. I would say that those probably the easiest ways. Yeah. Okay. So since this is already in slope-intercept form, if you remember, slope-intercept form is the y equals mx plus b, which shows you that when you line it up like this, it shows you that the number in front of the x, which when I don't have a number in front of the x, it's just a 1. Just no one writes the 1 because it just looks weird. But if there's not a number there, then you take it as a 1, which means my slope will be 1. So if my slope equals 1 over 1, that means it's going to be like a step. It's going to be 1 up, 1 across, 1 up, 1 across. From this point. And this point right here is my y-intercept. It is the point that I get when x equals 0. So when x equals 0, when x equals 0, when I plug in x equals 0 into this equation, y equals 1 times x, which is 0, minus 1, I get y equals 0 minus 1. So y equals -1. And when my x is 0, my y equals -1. Good job, Haley. So this is my y-intercept. It's the point. It's the point where when x is 0, my line meets the y-axis. So that's 1 point on there. 1 point that is definitely on this line. And my slope is 1 over 1. So I'm going to move, remember the slope is y2 minus y1. And you need to know all these. I mean, maybe I can make a t-shirt and just send them to you guys, but you need to know these formulas. So my top number And my slope is my Y business. It's the up and down of the line. And the bottom number is the X, which is the left and right. So from this point, I can go up one, sorry, down one. I'm so sorry, people are in and out of the. So from this point, my slope is 1/1. I'll go up one and to the right one and put a dot. From there, I can go up one and to the right one and put a dot. And that should be enough. Those 3 points, which I could have also gotten with the table of values thing. It's whatever is easiest for you. Once you're doing it, whatever you find the way that's easiest and you do it. So 0 minus 1, I pick 0. I could also say, well, if Y is 0, what do I get for X? Plug in 0 for the Y. X minus 1. I would move this -1 to the other side because I want to have my numbers on one side and my letters on the other side. So that can be another point. When X is 1, my Y was 0. Which is this point right here. When X is 1, I didn't go anywhere up or down for the Y. So it's still on the line. I can get points just this by this way. What is this? Sorry. I connect these. And I put the arrows at the end to show that the line goes forever in both directions. One line, that's, all of that is one line. Question so far? You guys have to talk to me. Like, if you don't understand, I need to know that you don't understand. We're not next to each other. No one's gonna make fun of anyone.
I understand.
If you don't and you are shy, please text me in the chat and I will set up a time when I can speak with you privately if you want. You want to make sure that everyone gets it. Let's do another thing on the same graph. Two. Two Y equals 3X. Okay. We didn't have one like this before, I don't think, but it's not like illegal. You can still have these kinds of things. We just need to focus on when X is this one, what is Y? Hold on. Okay, so this one, let's do the table of values. Might be easier. Since it's not in slope-intercept form, I'm not gonna try to figure out what the intercept is and what the slope is, because I'm lazy and that's just too much work. I'm just gonna use what I have. If it's like this with X and Y and no whole number, I'll just try to pick numbers that look good. And say when X is 0, I have 2Y equals 3 times 0, So I just have I divide by 2, both sides. Nothing divided by 2 is nothing. One of my points, 0, 0. And then I'll pick another number. I'm gonna pick, for X, I'm gonna pick 2. Because I want nice numbers to graph. So if X is 2, I have 2y equals 3 times the 2 that I just made up for X. So I have 2y equals 6. Divide both sides by 2. How about my handwriting is looking better today, right? I'm really getting the hang of this pencil thing. So X is 2 and Y is 3. And I really only need 2 points. So I'm just gonna plot those 2 points. 0, 0 is 1 point on the graph. And 2, 3. So X is 2. It'll look like this if this was a point. X is 2, 1, 2, and then up 3. 1, 2, 3. So those 2 I'm going to connect with the line. I'm just going to make the line as long as possible because I want to extend it to where I think it'll meet the other line. And then I'll go back and I'll extend this line. Oh my goodness. Ah, this is hard. Okay, let's see. So this is where they meet. I don't know where that is. If I had a better graph, I could figure it out and know for sure. I could also combine both of them and never have to graph it at all by writing both of the equations like this. One of them was y equals x minus 1. And the other one, where is it? Is 2y equals 3x. Y equals 3x. Okay, for me to combine them, I have to set them up in the same way. I like to set them up as in the this is the time that standard form is useful because it looks normal. I like to put the a, y plus bx equals c. So I'm going to switch around this one and put a minus x on the other side. It becomes minus x plus y equals -1. If anyone's saying, why is she doing all this mess? We already know that it meets, let's just move on. But we need to know exactly the point that it meets. And I can tell by my lovely graph. So I write it like that, ax plus by equals c, the x business, the y, and then the number. And then I'm gonna make this one be in the same format. So I'm gonna move the 3x over to the left side. It's gonna be minus 3x plus 2y equals what? Let's just leave it blank. I'm gonna put it 0 equals 0 because I don't have anything. And I want to make sure that I have everything in the x's, everything in the y's, and they line up nicely. And then just my numbers. Okay, so now this is, if you can get this, you're gonna be good for like until you're 30. I want to see what do I have to do to this equation to cancel out the x's, or what do I have to do to this equation to cancel out the y's? If I were to just add these equations together, I would end up with more of the same stuff. I want to do it so that they cancel out. If I just added these, I have, this is really a 1 in front of here, right? So -1, more negative, adding to a -3, that can give me -4x. Y plus 2y gives me 3y. -1 plus 0 is -1. This doesn't help me because I still have an x and I still have a y. I need to do something to, oh my goodness, to cancel out one of these things. So I'm gonna erase this red stuff. Oh my God. And I'm gonna see, I want to get rid of the y's. Okay, so if I want to get rid of the y's, I'm gonna have to add the opposite of them. If this is a 2y, I need to, for this to be a -2y, so that when I add them together, -2y plus 2y, they can cancel each other out and like poof and just disappear. So in order to make, like to force this to be a -2y, I'll multiply the whole equation by a -2. Like every one in that equation, I'm gonna multiply by -2. And I'm gonna write it over here very neatly. So -2 times -x gives me +2 x. -2 times y gives me a -2y. -2 times -1 gives me a plus. And I don't have to write the plus, but I like to because I forget. +2. And I didn't do anything to this equation, so I'm just gonna rewrite it on this side. -3x plus 2y equals 0. And now I'm gonna add them together because I hope that when I add them, someone's gone from there. Okay, so when I add these, I have 2 minus 3x, which is a -x, minus 2y plus 2y, that thing is gone. This whole thing is gone, it's out of here. Equals 2 plus 0. So I have -x equals 2. And I'm gonna change the sign of, because I don't want a negative variable. I'm gonna change the sign of this. And if I change this sign, I'm gonna change this sign also. So this becomes x. equals -2. And I'm gonna save that. I'm gonna like put a little sticky note up here. If I have that someplace. That says x equals -2. I'm gonna save that. And then I'm gonna take that -2 and plug it into one of my original equations. Okay, so I'm gonna plug it into plug it into this one, the y equals x minus 1. So I'll rewrite that. And I know that x is -2. I'm going to plug that in for this x here. So y equals -2 minus 1, which is -2. Taking away one more, I'm at -3. So I have x equals -2 and y equals -3. And that should be the point. That should be my point. That is over here someplace. My -2, comma -3 point. This should be the point that these two lines meet. Maybe on a bigger graph. Okay, so -2 and then -3. That should be my point. Does that make any sense? Not why would we want to do that, but does it make sense mathematically?
Yeah.
Yeah.
Yeah. Okay, this method, this is called system of linear equations because it's more than one graph, more than one line at a time. And this method is called the addition method. I take one line and I add it to the next line. I manipulate it a little bit to see what I can get rid of. Figure out my x and y point, and this point works in both equations. That's basically what that is. It's the same thing as graphing one and graphing the other one. If you have a nice graph, you can also solve by graphing. So this is another method. Solve by graphing. Systems of equations. That doesn't always work so easily. What if you have like a number like 11/4? Your graph has to be really detailed for you to solve that. There's another method, substitute method, but we'll see if we can use that. Okay, so let me put some more equations together, linear equations together, and we'll see if we can take our time and solve those. Let's solve these two. You want to solve by graphing or you want to solve by combining the two equations? Or you just want to cross your fingers and wait for multiple choice question? That's also another option.
Let's combine them.
Combine them, okay, let's combine. So to combine them, you want to write them both in the standard form. Which your standard form is AX plus BY equals C. Oh, what about the equals C? So that's the way that you will see most equations. So one of them is in standard form. What is that? Hold on. One of them is now in standard form, and the other one is in slope-intercept form. So we have to change this one around so that we can combine them. Okay, the one that's in standard form, I'll leave just like that. 3x minus 3y equals 15. And the x needs to go on the other side for it to be in standard form. So this will be a minus x. That's over here, minus x plus y. Equals 5. Can we combine them just like this without, or do we have to do anything to them?
Multiply by 3.
Which one by 3?
The negative x plus y equals 5.
Okay, so I'm gonna multiply the bottom one by 3. Oh, this is getting sloppy. The top one, I'm gonna leave just like it is. X minus 3y equals 15. And the bottom one, 3 times minus x is minus 3x. 3 times y plus 3y. And 3 times 5 is 15. So now I can add these together and get rid of something. So 3x minus 3x, that's gone. Minus 3y plus 3y, this is also gone. 15 plus 15, 30. So I have on this side, I have nothing, right? What does this mean? This is a hot mess. What does it mean when you get a equation that is not true and doesn't make sense? What does it mean for these two lines?
There's no solution.
There's no solution. If there's no solution, does that mean they don't meet? Or does it mean that I'm not gonna try to write no solution? No solution, does that mean that they don't meet? Or does it mean that they meet at one point or they never meet?
Isn't it they only meet at one point?
If they met at one point, then we would know the point that they were meeting. We would
Oh,
have,
it says
work with.
none.
right? So let's write our choices. They either meet at one point, meet at a lot of points, or they don't meet. At one point, we can scratch off that, right? They're not gonna meet at one point. Do they not meet
At
at
a lot of points?
They meet at a lot of points. That means they're meeting too much. They're meeting so much that we can't pinpoint the point that they're meeting. So it's no solution. So for us, that goes back to the other one where you meet at a lot of points. Of course, I can't find that graph. Yeah, I meet at a lot of points. Means that it looks like this. It's the same exact line. I'm gonna meet here, 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 here. I'm meeting at all of these points, so I'm the same line. I'm essentially the same line that I just multiplied by another number. Cause all I did to this was multiply by 3, and I got this thing, so I'm meeting at a lot of points on the same exact line. So how can you write that mathematically? Then you say, some textbooks say inconsistent solution. Because you have a solution, kind of, it's the same line, but it's not one thing that you can say. Or you can put the same line, if you have the actual lines are the same. Not the same slope, so that's different. Has anyone started to do any work in web assignment? No pressure, just asking for my personal knowledge. If you haven't, that's fine.
I have.
Yeah, and how's it going?
It's going good.
Okay. Oh. Okay, so let's graph 2x minus y equals 1 and y equals 4x minus 3. You can either graph them or combine the lines. Which one do you want to do? I'm going to combine the lines. So I have, I'm gonna write 4x minus 3 equals y. That's in my standard form. It's in ax plus by equals c form. No, it's not. I need, it looks kind of like it is, but I need this number by itself on this side. So I'm gonna switch the y and the minus 3. When the y comes over to the left side, it becomes negative. And then when the minus 3 goes to the right side, it becomes positive. This equation I'm gonna leave just like it is because it's already in standard form with the x, the y, and then just a number. I'm gonna write 2x minus y equals 1. And then, you guys need a break? I'm sorry. No, no need to break? Okay. So I can combine them. And if I combine this the way it is, I'm gonna end up with a minus 2y. So I'm gonna change the sign of this equation. So all I'm gonna do is rewrite this equation with opposite signs for him, opposite signs for him, and opposite signs for him. So minus 2x plus y equals -1. And then I'm gonna rewrite this equation the same way, because I didn't do anything to it. And now I'm gonna add these equations together. So minus 2x plus 4x gives me 2x. Plus y minus y is gone. Equals -1 plus 3 is 2. Okay. So I have 2x equals 2. I divide by the 2, because I want to get the x's by itself. X equals 1. So I'm gonna keep that. I'm gonna post that and keep that someplace. X equals 1. Then I'm gonna use this x equals 1 in one of my original equations to figure out what y is. So I'm gonna use it in that one. This one.
So do you always have to solve for x on the first one and then plug it in? Or can you
No,
choose which
You
one?
can solve for y.
Okay,
Yeah, you can, whatever's easier. I try to work with whatever's easier. So since this one was easier for me to get rid of the y's because they didn't have anyone connected to them,
mhm.
I got rid of those. I could have done this, but then I would have to multiply one of them by a 2.
Oh, okay, thank you.
Yeah, you can get, whoever you can get rid of first, go on and get rid of it. So x is 1. I'm gonna use this. I use this equation because my y is by himself already. So when I get the x, I don't have to be moving anyone. All my stuff happens on one side. So I plug in x equals 1. So y equals 4 times 1 is 4 minus 3. 1 minus 3 is 1. So my x is 1 and my y is also 1. So my point, my 1 point that would be a solution to both equations is x equals 1, y equals 1. So the point is 1, 1, 1 comma 1. So if I were to graph both of these lines, it would meet at this point. Because this is the 1 point that works in both equations. Okay, let us graph it and see if that is true. Okay. So this one is already in slope-intercept form with my slope here and my intercept here. Remember, slope intercept is y equals mx plus b. So I can look at this equation and see that my intercept is gonna be 0, -3. So my point will be 0 and -3, 1. And then I need another point on this line. I'm just gonna say when y is 0, what do I get? When y is 0, I have 0 equals 4x minus 3. I'll bring my 3 to the other side. +3. I divide both by 4, so I want to get x by itself. X equals 3/4. And I know that y is equal 0 because that's what I chose in the beginning. So x is 3/4. So this is the 1, and then it's like right here. And y is 0. So I draw this line. And then the other one, the 2x minus y equals 1. Let's do just 2 quick. If x is 0 and then y is 0. So if x is 0, I have 2 times 0 minus y equals 1, which leaves me with minus y equals 1. And I never want to have a negative variable, so I'm going to switch the sign of this and switch the sign of this one. So I have y equals -1. So when x is 0, I have y equals -1. X is 0, I don't move. And y equals -1. And then when y is 0, I have 2x minus 0 equals 1. So there's nothing to minus. So I just have 2x equals 1. I want to divide by 2 because I want to get x by itself. So x equals 1/2 when my y is 0. X is 1/2. We try to connect these two. I try to make it go past where I think that they will meet. And let me extend this other line. And this looks like it's about one where they meet. Which is what we got over here. X is 1, y is 1, and they meet. You just have to decide which way, because on WebAssign, they'll tell you solve by graphing, solve by the addition method, solve by the substitution method. They don't know which way you're doing it. So you don't have to listen to them. You can just solve the way that is easiest for you. But I will tell you, graphing is not the easiest method because you have to be very precise. Well, you can kind of eyeball it and then it's multiple choice. I mean. But either we're gonna do this, we'll do the, after the break, we'll do the substitution method so you can see. And then you can choose which method is easiest for you. Take a break for like 5 minutes. Good? Yes. No one talks to me. When are you guys gonna talk to me? Break for 5 minutes. And some will be show your work, because I feel like if you did all the work, but you missed like a minus sign, then you'll get the wrong answer. But I know that you know how to do it. You just messed up on that one thing. So I like to see the work so I can see where you messed up so we can fix that early on, you know? Plus, I know y'all just guess if it's all multiple choice, and I don't like that. So. Okay, let's see.
Sorry, I don't know if I missed this or if you, or when you said it, where are we gonna be taking the tests? Is it gonna be on WebAssign as well?
Yes, on website also. Mhm.
Okay, thank you.
Okay, solve the system of equations. X minus 2y equals 4. 3x plus y equals 5. Okay, you notice how both of them are already in standard form. So when they're both in standard form, I'm just gonna add the equations. I wouldn't even try to graph it because that's a lot of moving around. So when they're both nicely kind of set up for me, X, Y number, X, Y number, I'll just try to write it over like this and see what I have to do to one of them to be able to combine them and get rid of somebody. Okay, so my handwriting has gone back to crappy. I apologize. Okay. So you have choices. Do you want to get rid of the X's or do you want to get rid of the Y's?
Wise.
Y's. Okay, so if I want to get rid of the Y, this is a minus 2y. This needs to be a plus 2y. So I need to multiply the whole equation by a plus 2. Okay. Everyone in this whole equation multiplied by a 2. Okay. So the top equation stays the same because I'm not doing anything to it. The bottom equation, I'm multiplying by 2. So 2 times 3x is 6x. 2 times y is 2y. Two times 5 is 10. And I'm going to add these together. 6x plus x, 7x. minus 2y plus 2y, that was our goal, we're trying to get rid of that. 4 plus 10, 14. So I have 7x. And x equals 14. And divide by 7, both sides. I have x equals 2. I'm gonna keep that for my. What if I could change the color of my sticky? Yes, yes, I can. Hold on a second. Oh, who doesn't like a purple sticky note? Okay, so x equals 2. And then I'm gonna plug in 2 into one of my original equations. Which one do you want to use for the x equals 2? Oh, me, I'll choose the hard one since no one.
The first one.
Ah, the first one, okay. So x equals 2, I have 2 instead of x minus 2y equals 4. I move this 2 to the other side, minus 2. Okay, minus 2y equals 2. I want to get y by itself, so I'm going to divide by minus 2. And then divide the other side by minus 2 also. So this is gone. Y equals -1 because my negative sign is here. So now I have x equals 2 and y equals 1 equals -1. Sorry, you guys didn't even tell me that I made a mistake. Come on. Y equals -1. So my point that will work in both of these equations is x is 2 and y is -1. So both of these lines, when I graph them, which I don't even need to do, I just need to solve it. This is all it tells me to do, solve it. So I'm not going to try to do anything extra. Solve it and I solve it. Okay, this point will work in this one equation and this equation. It'll work here. 3 times 2 is 6 plus -1 is 5. So it works here and it works here. So this point works in both equations. It is a solution to that point. That means they're just 2 regular lines that meet at one point. Making sense?
Yes.
Let's see. That's another system. Okay, so fraction time, 3/5. X. 1/5 equals 5. Okay, so 3/5 x plus 1/5 y equals 5. With 4/5 x plus 3/4 y equals 7. You are welcome for that one. Okay, so I'm gonna divide it over. And what's the problem? Unless you like fractions, what's the problem with this? When you look at this, are you upset? And if so, why? Yeah, why?
I don't like fractions.
I don't like fractions. What if someone gave you a fraction of $1 million? Are you gonna say, no, I don't like fractions, keep your money?
Nah, I want the whole million.
See? Okay. Okay, so the problem is fractions, right? So we're gonna try to get rid of the fractions before, because although I like fractions, I do not want to be doing this multiplication, adding and stuff with all these fractions. So for the first equation, I'll look at the bottom numbers. So the bottom, okay, this is, I put over 1. I put my whole numbers over 1. Life is about balance. So I have 5 on the bottom. So to get rid of that, I'm going to multiply every term in this equation by a 5 to get rid of that fraction. I'll multiply the whole thing by 5 over 1. Okay, so 5 times 3 is 15. Over 1 times 5 is 5. I'll just write it like this so you can see that they disappear. 5 times 1 is 5. 1 times 5 is 5. Y equals 5 times 5 is 25. Over 1 times 1 is 1. Okay, so 5 will go into 15 3 times, and that's going to leave me with a 3x. 5 will go into 5 once. That leaves me with a 1y. But I don't want to write 1y, so I'm just going to write y. And this is just 25. So I got rid of the fraction by multiplying what was in common between the bottom numbers. This one, I'm going to look for a number that works for 5 and works for 4. What is that number going to be? Oh, it's a nice blue. A number that 5 can go into and 4 can also go into, the same number,
20.
20. So I'm going to multiply the whole thing by 20 over 1. So 20 times 4, oh, this is getting large, 80 over 5, 5 times 1, x. And this is a lot of work, and we haven't really done anything yet. We're just fixing our problems so we can start to do the work. So 20 times 3, 60 over 1 times 4. Y equals 20 times 7, 140. Okay, 5 into 80 goes 16 x plus 4 into 60 goes 15 y equals 140. Okay, I just rewrite that over here as neatly as I can. Yes. Now we can start to do some work. I forgot the Y. You guys gotta watch me. Goodness. I make mistakes. Okay. So do you want to get rid of the X's or the Y's?
X.
The X, okay, so we need to find a number that 3 can go into and 16 can go into.
32.
32. Doesn't work for 3. You know the trick to see if a number is divisible by 3?
Multiply them by each other.
32. To see if 32 is divisible by 3, what's 3 plus 2? 5. If 3 doesn't go into 5, if 3 doesn't go into 5, 3 won't go into 32.
45.
45? 45 work for 16? 45 divided by 16. Nope, this one's gonna be 3 times 3 times 5. And this is gonna be 2 times 2 times 2 times 2. Nope. You could always do 16 times 3 and use that number. Or you could give up on this and try to get rid of the Y's. Your choice. Get rid of the Y's. Good job, Olivia. Let's get rid of the Y's. So this is already a 15Y. We need to make this a minus 15Y. So I'll multiply the whole thing, all of the terms in this equation by minus 15. Okay, so negative 15 times 3 is minus 45 X. Negative 15 times Y is minus 15Y. My goodness. Negative 15 times 25, I don't know. Hold on. Don't look at what I'm doing, okay? It only makes sense to me. Um, 375. Somebody have a calculator? 75. Okay, and then this one stays the same. 16. Man, this is really ugly. 16x plus 15y. Negative 375. Thank you. Thank you for checking up on me. Come on. Okay. I'm gonna put these 140. I need a calculator. Okay, so. Oh my goodness, minus 45 plus 16. Oh, let's switch my head. 29. And then. Somebody have a calculator? I'll put the X part, wait for the answer. Is it 20 minus 29?
It's negative 29.
Yes, okay, minus. This is why we don't do a lot of fraction problems, but there will be one on test because I don't know, I think it makes your brain work in a nice way. Okay, so 0 equals minus 375 plus 140
It's negative
minus
35.
235. Okay.
Yeah.
This is just awful. Why would someone do this? Why would someone make up this problem? Okay, so I'm gonna divide both sides by minus 29. I'm gonna have x equals some positive number. Let's say 235. Oh, this is just ridiculous. You get a problem like this on the test, take your time and just do half. And then I'll know. I say you struggled already to do half. I know that you know what you're doing. Because this is, at this point, this isn't teaching us what we want to know. You know
On
what I
the
mean?
test and other assignments.
Say again?
Would you want us to, on the tests and other assignments, would you want us to break it down to a number?
Yes, if you can reduce it, then you should always reduce it. This one, I know 29 is a prime number. So there's gonna be no factors for that.
Yeah, it came to
So-
8.10.
But if you can reduce it, then you should, because it's just the right thing to do.
Okay.
We can always go back and plug in X for 235 over 29, but I'd like not to do that. Because basically I want you to be able to know that you can get rid of the fractions by multiplying by a whole number that works with both of the denominators, or all three if you happen to have three. That you need to pick which one you're going to get rid of and work the magic with the other equation. And that you need to, once you do find an answer for X, save it and then use it to plug back in and get the answer for Y. Okay, if you haven't started on any web assigned homework, please try one of the questions at least in each section. If you don't understand them, if you're stuck, please, my number's in the chat, 305-321-7794. Take a picture of it, a nice picture, not a grainy picture. Send it to me and then I'll work it out and send it back because I like math problems. Okay, I'm not trying to give you 100 problems just because it's homework. But I know if I don't give you something, no one's ever gonna say, you know what I need to do today? Instead of watching Netflix, I'm gonna do systems of equations. No one's gonna say that. So if I don't give you something, you'll never look at this again until Monday. Okay? Any questions so far?
No.
No? Okay, I'm gonna end class for today. If you have questions, you can stay after and I'm still here. Otherwise, have a good weekend.
Thank you. You too. Bye-bye.
Alrighty,
Have a good weekend.
you too.
Could you, is your number the 305-321?
That person's not marked. Is it?
Professor, is
Yeah.
your number 305-321-7794?
Yes.
Oh, okay. Just in case I have to,
Not a problem.
because I still having a problem with my book for some reason, and so I'm still trying to figure that one out. So, but I did get some help at the college, so I'm going to see if I could get that working today.
Okay,
But
Yeah.
just in case I have any questions.
okay, no problem.
Okay. Thank you very much.
You're welcome. Take care.
I got a question. So we're taking the test on WebAssign. Do you just give us a code or do I have to make an account?
Oh, you have to make an account. So you haven't been in there to do the homework, huh?
No, they just fixed my Blackboard thing like 3 days ago.
Oh my gosh. Okay, so yeah, you have to get the course, when you get are you on campus?
Am I what?
Are you on campus?
No.
No, okay, so you have to buy it from, I think, webassign.net. And you buy the scratch off thing. It's like a code you're gonna purchase
Uh-huh.
and you put your NNMC email and they're gonna email you the course, thing that you would scratch off.
Oh, okay.
And then once you do that, you go to WebAssign, you enter in the product code that you bought. And then it's gonna say, the course key. And did I give you the course key in the chat the other day?
I don't have it.
You have it? Okay, it's, and
No, I don't.
you don't, you do not have it.
Yeah.
I'm gonna write it here so that you can see it, because after you go in and you put in your product code, then you have to connect your product with our class. So this is the code that does that. And then MC 24984496. That's our course key, I think it's called.
I'm sorry, can you repeat that?
All right.
And that'll connect your product with what you bought, your book that you bought, with our class, with all of our assignments.
Alrighty.
And you're gonna take the test in the same place you do the homework.
All right. Well, I still have to, they also messed up my FAFSA thing, so I had to figure that out. I have to go back to Roswell to figure that out. So,
Okay, let me know tomorrow if you don't get it figured, because there's like a 2-week trial key that you can use.
I won't be able to figure it out until at least Saturday, because I have to go back to where I used to live.
Okay. Okay, so I'll email you the code. Who is this? Who's talking, Jared?
Yes.
I'll email you the code that you can use for 2 weeks, okay?
Okay, thank you.
Okay, no problem. All right,
Have a good day.
you too.
Is the class for Monday posted, like the recording?
I haven't figured out how to do that yet. I have it and everything. I have to figure out how to do it. But
Okay,
I'll figure that out tonight. I swear I'll figure it out tonight.
okay, that's fine. No, I was just wondering because I got discharged yesterday and then everything's barely like logging on now, like everything's connecting, so
Yeah, so maybe you should still wait a little bit, because I don't know.
no. I was just making
Mhm.
sure because I looked and there wasn't anything, so I was just like
I don't-
wondering if it is
see?
my computer or not.
Oh, no, it's me. I am, I'm technically challenged, as my children say. Like, so,
It's a all right. Well, thank you and have a good weekend, ma'am.
okay, no problem. Bye, Sarah.
Alrighty. I just want to say thank you
You welcome.
and have a good one.
All right, you too. Bye, Jose. Thank you.
Bye.